Picture it, Sicily. Sorry, couldn't resist. Imagine you go into a classroom and a student raises their hand and says, I don't get it. You have a split-second decision to make. Do you step in and help, or do you step back and help? Sometimes we're too fast to step in and rescue them, and we don't let them actually go through the productive struggle of learning. And then on the other hand, sometimes we wait too long and they start getting frustrated and then they put up a block to learning. And other times we misdiagnose the problem entirely. It's that fine line between helping, not helping, letting them struggle versus them starting to drown in frustration. The real question isn't, should I help? It's, why are they stuck? We have to diagnose the situation. This becomes the decision filter that we need to automatically go through when a student says, I don't get it. Hi, I'm Michelle from Thinking Math Corner, and I've helped thousands of students engage in learning through productive struggle, not memorization. I've also helped lots of teachers to be able to engage in those practices and produce students that do persevere and engage with the material and take a bit off your plate too as a teacher. At the base of all diagnoses, there are three types of stuckness. There's procedural stuck, conceptual stuck, and fear-based stuck. And how we deal with each of those is very different. For the first type of stuckness is procedural stuck. And that's when a student has a gap in the skill or has missed a piece of the procedure. And one of the things that you'll notice is it can result in a feeling of not knowing any of it when it's just that one little piece of the step of the procedure. For instance, they forgot how to distribute, or they put run over rise instead of rise over run for slope. Okay. So the teacher move for that is to help, but narrate the thinking. As I tell my students, we're going to channel your inner Ms. Muggeridge. And it's talking through why we're doing what we're doing to make it make sense, but also so that they hear it, feel it, and see it. Those three different modes of input help to solidify their understanding and help it stick to their brain even more. So let's talk through an example. If we took the distributive property example, maybe it's 3 multiplied by x plus 2. And we're looking at it, we're going, well, what's the operation between 3 and x plus 2? They're side by side. What does that mean? What happens there? And my students would generally go, that's multiplication. I'm like, okay, great. So that means we have 3 groups of x plus 2. So we have x plus 2 plus x plus 2 plus x plus 2, just like we did back in grade 2 or grade 3 when we talked about multiplication being groups of. And then I'd say to the student, 3 groups of x equals what? Guiding them through, showing them, narrating what I'm thinking in my head. 3 groups of 2, 6. They would write down the answer. If I feel like a student needs a little bit of extra support or an additional example, I'll go and find a different example with different numbers, but I would ask them to talk me through it. Tell me how you would solve it and why. Talk out loud to me. And that ability to articulate their thinking solidifies even more their understanding from what we had done previously. With procedural stuck, you're not just fixing the step, they're channeling their inner teacher. It's a way to model our self-talk, our problem solving, how we're starting, what we're thinking. You're giving scaffolding, not answers. So the teacher move for procedural stuck is guided support with thinking aloud. The second type of stuck is conceptual stuck. And that's a much deeper issue because the student doesn't know what's happening. They might be solving equations and not understand why we're using inverse operations. Why do they work? Why are we even talking about it? Why are we getting rid of things or canceling things out? That ability to make 1 or 0, depending on whether we're adding and subtracting or multiplying and dividing, they don't understand why we're doing that. It could be the same as them plugging in numbers into a trig ratio and not understanding why they're choosing sine over cosine and tangent. With this type of stuckness, rescuing does the most damage. It creates dependence on teachers or on their classmates. It equates hard with the teacher will save me. It also creates this illusion of learning. We've all been there. Someone has explained a concept to us so clearly and so succinctly that it seemed obvious. We understood it. We say, no problem, we've got it. Except that when they left and we tried another problem, we were lost. It was that illusion that it created. So when we over-rescue students with conceptual stuckness, we create a dependence. Heard becomes a four-letter word. And heard is how we learn things. But we want to make sure that we understand that heard is just a little bit outside of our comfort zone. It's not about drowning. It's that productive struggle, something that's just a little bit of a stretch for us to understand. But we don't learn new things through doing things that are easy for us. We learn new things by doing things that are hard. We can do hard things. The teacher move for conceptual stuck is to pause and ask questions. What does this represent? What do you think we're going to do next? What's the difference between this line and that one? In the description below, I've linked my free 3 thinking triggers guide. And it goes through 3 triggers to be able to use with students to promote thinking. In conceptual stuckness, we have to ask the questions to guide the students to their understanding. So for example, if we're solving equations, I often start with, what's our end goal? What are we trying to do? Because they look at this equation like it's a foreign language. It is, it's math. But they look at it and go, I don't even know where to start. And I'm like, okay, well, where are we ending? What's our goal? We need to find the value of X or Y or whatever the variable is. So that gives us somewhere to start with, because if we need that, well, what do we need to undo? What do we need to move in order for that to happen? Okay. The other example that I use frequently are fractional coefficients. And we just finished doing this with my students in class. And they would often, the minute they see a fraction, they freeze. And they're going, I don't know what to do. I'm like, okay, well, do we know what our last step is supposed to be? Yes. Okay. So what's the problem? Where are we getting stuck? The fraction. I'm like, okay. Is it the entire fraction? And we come to figure out it's the dividing by the denominator that's the issue. That's what makes a fraction, really. And that piece, then they know where to focus their attention and they can do with that. And then fractions become less scary. One key piece with the teacher move for this stuckness is the pause part. Silence is our friend. We have to let the silence breathe, and we have to be okay with that. And that's something that takes time and practice. One of the things that I've noticed is that students are masters at waiting us out. They have years of experience where they've waited long enough for a teacher to dive in, rescue them, and do the work for them. It's why we're seeing so many conceptual gaps at higher and higher grades. One of the things that I do with my students when I ask them a question for this type of stuckness is I will wait. If I see that they're having that kind of thinking look on their face, I wait. If they kind of look like they've blanked out, then I ask the question in a different way. And I'll say, oh, what do you think about that? I need something. And usually they'll give it to me, as long as they know that I'm expecting them to take a driver's role in their own learning. They have to take control of it. And I'm not taking that seat. So when we do that, that silence is so key, because it puts students into the driver's seat, taking something off our plates and allowing us to play the facilitator role as opposed to the fountain of all knowledge. Conceptual stuckness really needs space, silence, not speed. So what we're doing there is pausing and asking questions. In our third type of stuckness, fear-based stuck, it is all about the emotions. I don't know how to do this. I suck at math. I never understand this. The emotional toll is huge. But it's not an academic issue. It's not a cognitive ability issue. It's about the fact that we have gotten emotional about it, and therefore we start to shut down. And if we expect productive struggle with a fear-based stuck, we're going to have panic and shut down. No learning is taking place. We can't approach it that way. With fear-based stuck, we need to decrease the emotional toll. And we do that by normalizing struggle. So when students are really upset about it, And I'm like, what's happening? I'm just so frustrated. I'm like, is your brain working overtime? Yes. Like, that's a good thing. That means that your brain is trying to make those connections. That's how we get better at things. We don't get better at things by doing things that are easy. We do get better at things by doing things that are hard. You can do hard things. And decreasing that emotional piece and maintaining the thinking, that's where we need to be headed with fear-based stuck. So the teacher move for fear-based stuck is normalize the struggle, decrease the emotional, and then guide students. Us teachers, we tend to fall on one of two sides of the equation when it comes to helping students. We either overhelp, over-rescue, over-scaffold, all with the best of intentions. We want to help. Or we say, nope, we're not going to help. You need to learn it. You know this stuff. But somewhere in the middle is where we need to fall. And it starts with diagnosing the situation correctly. One of the things that I am working on with students is making sure that I'm diagnosing the problem before I jump in with a solution. The solution might not even fit what the problem actually is. So one of the three questions you need to ask yourself before you jump into a situation is this a skill gap? So it's a procedural stuck. Is this a thinking gap, which means it's a conceptual stuck? Or is this an emotional block? So it's a fear-based stuck. And those three questions can help you train your teacher muscle memory on what teacher move you need to use when. The diagnosis section is so important. These type of tiny shifts that make a huge difference in your classroom are a big part of what we do in the Think Studio membership. If you're interested in looking at it, check the link below. At the end of the day, all of these type of stuckness require a common action, a 5-second pause. It can be the deal breaker. Pause, evaluate, diagnose, and then help. In the video on the screen, I go through different types of diagnosing situations and what are some teacher moves that you can use for those situations.